When you look at a map of the internet, it kind of looks like this, just a chaotic web. But this is the hidden world that, well, basically powers our entire lives. So let's dive in. We do this dozens, maybe hundreds of times a day, right? You click something and a web page loads. We never even think about it. But what is actually happening in that split second? It's this lightning-fast, totally invisible journey across the globe, and we're about to see what's really going on behind the screen.
So to really wrap our heads around this, we're going to follow a single, tiny piece of your data on its journey. Imagine we're shrinking down and literally riding along with the very first message your computer sends out. You ready? This is the secret life of data.
Okay, so it all begins right here, with us. It's what the pros call the application layer, which is just a fancy way of saying the part of the internet we actually see and touch. Our web browsers, our apps, and that simple little click, well, it's about to kick off a massive, hidden chain reaction. Think of HTTP as the official language of the web. When you click a link, your browser doesn't just send out a vague signal. Nope. It writes up a very specific message, an HTTP GET request. It's basically your browser politely asking a server, "Excuse me, could I please have the contents of this web page?" And right away we hit our first little problem. We use these easy-to-remember names for websites, but the internet itself is a world of numbers. The computers out there, they have no idea what filesource.com means. They need a numerical IP address. So, how do we get from a name to a number? Well, the answer is this amazing thing called the Domain Name System, or DNS, and it is literally the phone book of the internet. Your computer makes a super quick call to a DNS server, which looks up the name and instantly gives back the correct IP address. And just like that, our message now has a real, deliverable address. Okay, so our request has an address. Awesome. But you can't just throw it out there into the wild. It needs to be packaged properly for the journey. And that happens by moving down through these different network layers. This whole process is called encapsulation. And honestly, the best way to think about it is like putting a letter inside a series of envelopes. Each layer of the network adds its own wrapper, its own envelope, with very specific instructions. This makes sure that the data not only gets to the right place, but that it can be understood when it arrives. So the first envelope gets added at the transport layer. First, it chops our big message into smaller, more manageable pieces. Then it adds something called a port number to the wrapper. Think of this like an apartment number on an address. The IP address gets it to the right building, but the port number gets it to the right apartment. In this case, the web server program, not, say, the email program. Next up, that first envelope gets stuffed inside another one at the network layer. This creates what we call an IP packet, and this is where that IP address we got from the DNS lookup finally gets used. The source and destination IPs are stamped right on the front. This is the main address that's going to guide our packet all the way across the globe. Our packet is almost ready to go. It's addressed for this huge global journey, but it has one last, very local problem it needs to solve. How does it physically get from your computer to your Wi-Fi router, which is literally its first step out the door? See, to solve this, you gotta know that every device uses two kinds of addresses. The IP address is like your global mailing address, and it can change. But the MAC address, that's a permanent physical hardware address. It's like the serial number for your network card. It's only used for that final, hyper-local communication. So, to get to the router, your computer needs its physical MAC address. It uses something called ARP, the Address Resolution Protocol, to find it. And it's basically your computer shouting across your local Wi-Fi network, "Hey, who has this IP address? I need your MAC address, please." The router hears that shout, and it calls back with its MAC address. And now the final wrapper is applied at the data link layer. That whole IP packet gets placed inside something called a frame, and that frame is addressed to the router's MAC address. This is the last envelope, and it's what gets our packet out the door. And just like that, our packet is on its way. It's left our house, our local network, and now it's out on the open internet, which is just this massive, sprawling maze of interconnected routers. Every single router out there is like a postal worker at a giant sorting facility. It looks at the destination IP address on our packet, checks its own map, and makes a split-second decision on where to send it next to get it one step closer. This happens over and over, hop after hop after hop, across cities, countries, and even under oceans. But, what happens when the internet gets really busy?
Well, just like a highway, it gets jammed up. If way too many packets show up at a single router all at once, you get a digital traffic jam. We call this internet congestion, and that router's little waiting area, its queue, starts to fill up really, really fast. And this is where it all connects back to you. When that queue gets full, packets have to wait longer, and that causes delay. That's your Netflix show buffering or your online game lagging. If the queue is completely full, the router just starts dropping packets altogether. And then your computer has to send them all over again, which, you guessed it, can make the traffic jam even worse. Okay, let's just say our little packet is a total hero. It navigates the maze, dodges all the traffic, and after dozens of hops across the globe, it finally arrives at the destination server's network. And now, that whole encapsulation thing we did? It happens in reverse. The server starts unwrapping each envelope. The outer frame gets torn off. Then the IP packet. Then the TCP segment. And finally, the original pristine HTTP GET request is delivered right to the web server application. The server now knows exactly what you asked for. But wait, the journey is only halfway done. The server has our request, but now it has to send the entire web page back to you. So it packages up all that text, all the images, all the code, and sends it all back on the exact same kind of journey, just in reverse. But here's a cool thing. On the trip back, not all data gets treated the same. Networks use a system called quality of service, or QoS, to prioritize certain kinds of traffic. And this really matters for our experience. Data for a real-time video call is super sensitive to delay, right? So it gets put in the express lane. An email, which can wait a few extra seconds, might travel in the slow lane. This is how we get a smooth, uninterrupted stream for the things that need it most. So just think about all that. From your simple click, to the DNS lookup, the multi-layer wrapping, that globe-spanning journey through traffic jams, and the final unwrapping, it all happens faster than you can blink. It's like this hidden symphony of protocols, all playing in perfect time, just to load one web page. And that, right there, is the incredible magic that makes our whole connected world even possible.